Hello, welcome back to the third in our Hevylite educational series. My name is Cornelius Willesey and I'm a medical science liaison at the Binding Site headquarters. Today I'm going to discuss the common limitations experienced when measuring monoclonal proteins in laboratories. The measurement of monoclonal proteins is currently performed by using serum protein electrophoresis, SPE, capillary zone electrophoresis, called CZE, and Hevylite on the Optilite special protein analyzer. However, there are several limitations when measuring monoclonal proteins with SPE and CZE. Today, we will focus on these laboratory limitations of SPE, specifically with regards to measurement of IgA in IgA multiple myeloma. However, many of these limitations occur across all electrophoretic methods. As discussed in our first video in the series, the International Myeloma Working Group, INWG, has recognised the limitations of SPE in the specific patient group and recommend measurement using nephelometric total IgA quantitation. However, this method also has a limitation and does not account for the polyclonal IgA background. These limitations go beyond IgA and can cause issues in measurement of other immunoglobulins. There are several limitations associated with SPE which make interpretation challenging. These include co-migration, multiple peaks, disaturation, broad migration, and precipitation. Let's break these down in more detail, starting with co-migration. When measuring IgA proteins with SPE, IgA does not typically appear as a distinct band and often co-migrates with other serum proteins such as transferrin and complement protein C3. In this example, if we overlay a SPE spectrum from normal human serum with a spectrum of a sample from an IgA monoclonal gammopathy patient, we see how monoclonal IgA kappa co-migrates with transferrin in the beta-1 region of the gel. Therefore, accurate quantification of the IgA kappa protein by SPE or CZE is challenging. Moving on to the second limitation of multiple peaks. Monoclonal IgA can exist in both monomeric and dimeric structure, but can also migrate as larger oligomers forming multiple peaks. These multiple peaks make it extremely difficult to accurately quantify the monoclonal component. Which peak is the correct peak to choose to quantify? The third limitation, disaturation, shown here with an IgG patient sample, demonstrates nonlinear concentration in this example of a very high concentration monoclonal protein giving an SPE result of 44.9 grams per litre. However, the total IgG result is 64.9 grams per litre. Here, the SPE is underestimating the monoclonal protein due to saturation of the dye on the gel. The fourth limitation is the protein producing broad bands on the gel. This occurs when the monoclonal protein migrates as a broad band in the gamma region of the SPE. In this example patient, at presentation, the monoclonal brand was very large, as seen on the left, but was difficult to distinguish from the polyclonal background following treatment, seen on the right. Finally, there is a fifth common limitation, which is precipitation at the point of application onto the gel, especially large pentameric IgM. This may result in an underestimation of the monoclonal protein by SPE. In this example, there is a significant discrepancy between the SPE quantification of monoclonal protein and total IgM by nephelometry. In addition to these 5 limitations which make interpretation of the result challenging, a study by Katzman and colleagues found that the measurement of monoclonal protein by SPE has a large variability below 10 grams per litre. This means that the measurement of proteins below 10 grams per litre can be inaccurate. When monitoring a patient, it is pivotal to accurately measure fluctuations of monoclonal protein concentrations. Due to the limitations discussed above, we have seen in 4 studies shown here that IgA is non-quantifiable by SPE in approximately 44% of cases. Hevylite and Optilite overcomes these limitations by simplifying measurement of the monoclonal protein during monitoring of patients with multiple myeloma. It achieves this by providing a quick and simple, non-subjective, quantitative measurement of both the involved and uninvolved heavy and light chain isotype. Hevylite are a set of 6 unique immunoassays exclusively available on Optilite special protein system. Hevylite assays enable the separate measurement of heavy and light chain isotypes. This provides the ability to conduct individual measurements between both IgG kappa and IgG lambda as an example. Hevylite has been shown to remain linear well below 10 grams per litre down to 0.8 grams per litre when measuring IgA. Thank you for watching this third video in the Hevylite series, and look out for the next video which will focus on immunopresis and Hevylite. Please feel free to reach out for more information on how Hevylite can assist you today in your laboratory.